The good news about this molar conversion review is you already know almost all of this. I'm going to teach you one more little bit of math, which might seem complicated, but after a couple of times of practice, it will be super duper easy. How many remember my make a plan slide? Nobody? What if I just showed you and it looked like this? Now how many people remember it?
Yeah.
Yes. I would like you not to memorize this, but to internalize this. It is very, very, very important that you're able to do this super easy. Because this here, as our plan, is going to get more and more complicated. In this unit, it's not, though. It's going to be super easy. We're going to start at moles and go to atoms, or particles. Start at moles and go to grams. Or we're going to start at grams and go to moles. Or start at atoms or particles or number and go to moles. Or we're going to do the really, really hard step. Start from here and go to here. Or start from here and go to here. Does everybody remember how to do that? Because I'm going to give you the opportunity on this slide, without any numbers, to go ahead and show me you know how to do this. Complete with a bracket. Ready to go. There's 6 of them. Please write them in your notebook. After you've made your plan, please make a bracket executing your plan with no numbers in it, although you can put Avogadro's number in there. Okay, so you might realize that in order to get from grams to moles, what do I need? Molar mass. I put that on top of my arrow. And I don't even know what it is, so I'm not going to use the actual molar mass. But when I build this bracket, I put grams here on the top. And then molar mass is in grams per mole, right? Where does the grams go? On the bottom, because that's what I need to cancel. And then they cancel. How do I get from moles to molecules? Avogadro's number. So I start with moles. And then what goes on the bottom?
Moles.
Moles, because that's what I want to cancel. For every 1 mole, I get 6.022 times 10 to the 23rd molecules. Having done that, can you do the rest now? Hopefully. Okay, to get from formula units to moles, what do I use? Avogadro's number. Did formula units confuse anybody? Formula units is like molecules, but for ionic compounds. I can't call it a molecule because ionic compounds don't make molecules. So my formula units cancel, and I'm left with moles. Did you get them all? Maybe? How do I get from moles to grams? Molar mass. So then I go moles, grams per mole. And my moles cancel. And now I'm at grams. Grams to molecules. Can I go straight from grams to molecules? I need 2 steps, don't I? So I'm going to go grams to moles, using the molar mass, moles to molecules, using Avogadro's number. So I start at grams. Grams per mole. My grams cancel. Now my moles. 6.00 times 6.022 times 10 to the 23rd. Writing is apparently hard today. Molecules for every mole. Moles cancel, and I'm left with molecules. Then for the last one, hopefully you can see that it's just the opposite direction. I'm going from formula units to moles to grams. That's using Avogadro's number, and then molar mass. So I have my formula units. And 6.022 times 10 to the 23rd formula units for every mole. Formula units cancel. And then grams per mole. Moles cancel. These are the only 6 steps you're going to use in this unit. That's it. We're going to use them a lot. And we're going to have lots of strange and interesting ways that we do it. And it might seem like I'm wasting a little bit of time, but bear with me and you will see how useful these things are. Is everybody comfortable with those 6 steps? That is not for you. That means we've got 14 minutes. Super. Because we've got to learn one new thing. We need to determine molar mass of compounds. And we already did one, right? Didn't we do water? What did I tell you water was? 1802, right? How did I get 1802? Add what together? I added 16 for the oxygen, 1.01 for one of the hydrogens, and 1.01 for the other one. That's how I got to 1802. That's what we're going to do, but we're going to do it. We're going to start with sodium chloride. Let me show you the way in which I do these. So the first thing I do is I write sodium equals 1 times, because I only have 1 sodium, right? What's the molar mass of sodium?
22.99.
22.99. And then chlorine is going to equal 1 times, I know this one, 34.45? Is it 34.45 or 35.45? 35.45, right? Let's make sure we get that right. And then, I'm not going to do any more math with that. I'm going to go straight here to my mathing machine, and I'm going to write 22.99 plus 35.45. Enter, and I get 58.44. How many people got 58.44? You're wrong. How How many people got 58.44 grams per mole? Nobody raised their hand. Well done. Good. Okay, now we're going to make it a little bit harder. Everybody ready for it to be just a little harder? Good. Carbon dioxide. So I'm going to write carbon equals 1 times 12.01, yes? Oxygen equals 2 times 16.00. I'm not going to do that math there. Everybody watch my calculator. This is the way I do this math. 12.01 plus 2 times 16.00. Does everybody see how I did that? That's going to equal 44.01 grams per mole. Okay? Okay, I'm going to make it even harder. Yes. Look at this. How many coppers do I have? What's its molar mass? 63.55. How many nitrogens do I have? 2. Because this right here, what this means is there's 1 copper in the middle, and I got a nitrate over here, and a nitrate over here. Everybody see that? That's what this means. So that means I have 2 nitrogens. So 2 times 14.01. How many oxygens do I have? 6. 6 times 16.00. And I go to my mathing machine and I get an answer. 63.55 plus 2 times 14.01 plus 2 times, 6 times 16.00. 187.57. Okay, so I want to talk about something now. Do I have the right amount of sig figs? Is that what you were going to ask?
No.
Great question. Let's wonder about these sig figs real quick. Didn't I tell you that we should only have 4 sig figs? Or did I tell you that we're always going to go to the hundredths place? Hundredths place, right? So once we go over 100, our molar mass can have more sig figs. Can I increase the amount of sig figs by multiplying? No. When I multiply or divide, I'm supposed to have the same amount of sig figs. So how is it possible I added sig figs here? Because this is actually addition. It's 1 of these plus 1 of these plus 1 of these plus 6 of these. So I'm actually adding those up. So that's the way in which we can get more sig figs when we have larger molar masses. Is everybody good with that? Okay. Here's one for you to do. Should be pretty easy. Ready to go? This is why you have that mathing machine on your desk. How many people got 2.34 grams per mole of sucrose? Okay, do you feel like you can do these? Okay. Good, because we're going to need this skill when we start doing these. So right now we're going to convert this from formula units to moles. So I'd like you to gups this up with me. Stay with me. So the first thing I'm going to do is I'm going to write down my given. My given here is in formula units. My unknown is moles. When I make my plan, it's formula units to moles using Avogadro's number. Just like we did earlier, right? The same plan. So then when I solve this, I'm going to go 2.34 times 10 to the 24 formula units of sodium chloride. And then I'm trying to cancel formula units. I know I'm using Avogadro's number. So on the bottom I need 6.022 times 10 to the 23rd formula units of sodium chloride for every 1 mole of sodium chloride. This then cancels here. This cancels here. Then I go to my mathing machine. 2.34 times 10 to the 22nd divided by, and because I'm dividing by Avogadro's number, I need to use parentheses. Open parenthesis, 6.022 times 10 to the 23rd, close parenthesis, enter. Uh-oh.
You did it to the 22nd instead of the 24th.
This should be 24, right? There we go. So I get an answer that looks like 3.8857. So now, of course, I'm going to do my Sparta check. And feel free to write on your paper MSUS and do the Sparta check. Math. This is essentially 23.4 times 10 to the 23rd divided by 6 times 10 to the 23rd. So I should get a number that's near 4. So my math makes sense. Sig figs. I have 3 there. I have 4 here. I should have 3 in my answer. So it's going to be 3.89. Units. I was looking for moles. I canceled. I have moles. Species should be sodium chloride. Good? Let's do another. This one's going 85 grams of carbon dioxide to moles of carbon dioxide. 85 grams of carbon dioxide to moles of carbon dioxide. So I've given grams. Unknown is moles. My plan is going to be grams to moles. And I'm going to use my molar mass. And fortunately for us, I had to do this a few minutes ago, right? Does anybody remember what that molar mass is?
44.01.
44.01. If I know it, I'm going to write it right underneath. If I don't know it, I'm going to go off and find a spot over here, and I can just do that molar mass right there. Okay, so when I solve this, I'm going to start with my given, which is 87.5 grams of carbon dioxide. And we're trying to get the moles, so I need grams on the bottom, moles on the top. And we said it was 44.0. Go to my mathing machine. 87.5 divided by 44.01. Before I even hit enter, what number should this be near?
2.
Should be near 2, right? So I got 1.988. here I have 3 sig figs, here I have 4 sig figs, so I'm going to be limited to 3. So this is going to be 1.99. And of course, we're going to do our Sparty check. We're checking for math, sig figs, units, species. I can see the math makes sense because it should be near 2, and it is. My sig figs, we just did that, should have 3 sig figs, and it does. My units, I was trying to get to moles. That cancels with that, so I am left with moles. And my species is carbon dioxide. Questions on how to do that, guys? Okay, this one looks like formula units all the way to grams, doesn't it? Formula units all the way to grams. So I'm going to go given formula units, unknown grams, plan, formula units to moles using Avogadro's number, to grams using the molar mass. And fortunately for us, we just figured out what the molar mass is, right? What is the molar mass? Because we just did this one, didn't we? Copper 2 nitrate? 187.57. Okay, good. Let's solve this guy. 8.15 times 10 to the 22nd formula units of copper 2 nitrate. Does it seem like I'm writing a lot of extra stuff here that I could probably do away with and not waste time on? The reason I'm doing that is because later it's going to matter. Because we're going to go from moles of one substance to moles of another substance. So we have to track our species all the way through our brackets. Okay, so that I know 6.022 times 10 to the 23rd formula units of copper 2 nitrate for every mole of copper 2 nitrate. That cancels that. Now I'm at moles, so I need 187.57 grams of copper 2 nitrate for every mole of copper 2 nitrate. Moles cancel, and I'm left with grams. I go to my mathing machine. And I go 8.15 times 10 to the 22nd times 187.57 divided by, and because I'm dividing by Avogadro's number, have to open parentheses. Please work along with me so that you know that you can do this. 6.022 times 10 to the 23rd, close parenthesis, and I get this amazing number of 25.385. Okay, let's do my Sparty check. MSUS. Math. Should I get a number near 25? Yeah, I should get about. That makes sense. How about sig figs? How many should I have? There's 3, there's 4, there's 5. I should be limited to 3. So it should be here, 25.4. My unit is in grams. I was trying to get to grams, and I got the grams. And it's copper 2 nitrate. And I've got my answer. We definitely have time for one more, right? No, we probably do not.